All right, so get this. You send a bunch of researchers off to build like the super powered AI, and they come back with a multi-layer perceptron.
Really?
That's right. We're diving into absolute unit neural networks, or AUNNs.
Ugh.
They're kind of shaking up the world of artificial intelligence.
Wow.
So you might be thinking, wait, aren't those old school neural networks? Well,
Yeah.
yeah, but here's the twist. AUNNs are basically just these giant MLPs that try to memorize a massive data set. And by memorize, I mean they learn to predict any piece of data within that data set just by knowing its location.
Oh,
No fancy recurrent networks, no attention mechanisms, just like pure raw memorization power.
wow.
We've got a stack of research papers and articles on this, and honestly, some of it sounds like straight up science fiction.
Yeah, I can imagine.
It seems crazy to think that a simple MLP could handle the complexities of language or image recognition, let alone something like reinforcement learning, just by memorizing data.
It's definitely a bold idea, and that's what makes it so intriguing.
Yeah.
AUNNs are turning a lot of conventional AI wisdom on its head.
Right.
We've been so focused on building ever more complex architectures like transformers that we might have overlooked the potential of scaling up simpler models.
So instead of creating like specialized neural networks for each type of task, AUNNs are like, hey, what if we just build one massive network that can do it all?
Exactly. It's about pushing the boundaries of what's possible with scale. And early research suggests that with enough data and computational power, AUNs might actually be able to achieve performance comparable to or even surpass these specialized models.
Okay, so let's unpack the main points about AUMNs, starting with their simplicity.
Right.
It seems like ditching the complexity of RNNs and transformers for a straightforward MLP structure would have some major advantages.
Absolutely.
What do you think?
For one thing, this simplicity could be a game changer as computing hardware evolves.
Okay.
Modern hardware is becoming increasingly optimized for dense matrix multiplications, which are the core operations of MLPs.
So AUNNs are kind of like riding the wave of hardware advancements. It's like they're perfectly positioned to take advantage of the way computing power is developing.
Precisely.
Okay.
As hardware continues to improve, AUNs could become even more efficient and powerful, potentially outpacing more complex architectures.
But can these simpler AUNNs actually perform as well as the big dogs like RNNs and transformers, or are we just talking about potential here?
Well, the research is still in its early stages,
Okay.
but there's growing evidence that AUNNs could hold their own against more established architectures.
Really?
Think back to other moments in AI history where simpler models have eventually overtaken more complex ones as data and computing power increased.
Okay.
Decision trees versus logistic regression, or even transformers themselves versus convolutional neural networks.
So it's kind of like a tortoise and hare situation.
Uh-huh.
The more complex models get a head start, but the simpler models like AUNNs might have more stamina in the long run.
That's a great analogy.
Yeah,
And with AUNNs, we're seeing some early signs that this might be the case.
that's fascinating. It really makes you wonder if AUNNs could be the next big paradigm shift in AI, even if they seem kind of counterintuitive right now.
That's what's so exciting about this field. Sometimes the most groundbreaking ideas are the ones that challenge our assumptions and force us to rethink what's possible.
Okay, let's move on to another mind-bending aspect of AUNNs, meta-learning.
Okay.
How can these models learn to learn when they don't have any of those fancy meta-learning mechanisms built in?
This is where the sheer scale and memorization power of AUNNs comes into play.
Okay.
Imagine the entire AUNN as one giant hidden state, storing all the knowledge gleaned from that massive data set is memorized.
Right.
As it encounters new data and tasks, it can tap into this knowledge base and adapt its behavior accordingly.
So it's like the AUNN is constantly building this internal model of the world based on everything it's learned.
Yeah,
And then it uses that model to solve new problems, even if those problems are different from what it was trained on.
exactly.
Right.
It's an emergent property of the AUNN's structure and training process. It doesn't need explicit meta-learning algorithms because its vast knowledge base allows it to adapt and learn on the fly.
That's wild. And to think this approach might actually have some parallels with how the human brain learns. I mean, we don't have specific meta-learning algorithms running in our heads, right? We learn from experience by building these vast interconnected webs of knowledge and associations.
You're exactly right, and that connection to human cognition is what makes this research so compelling.
Yeah.
It suggests that AUNNs might be tapping into something fundamental about the nature of learning and intelligence.
Okay, let's bring this down to earth a bit and talk about a specific example from the research that really caught my eye. It involves using AUNNs to reconstruct those damaged Herculaneum scrolls, the ones buried by the eruption of Mount Vesuvius.
Yes, that's a fantastic example of how AUNNs could be applied to real-world problems, especially in fields like archaeology or historical preservation.
Hmm.
Imagine training an AUNN on various scans of these scrolls.
Right.
It could learn to predict the missing information based on its understanding of the underlying structure and patterns of the text and materials.
So the AUNN essentially becomes an expert on those scrolls. It can fill in the gaps and reconstruct the missing pieces based on its vast knowledge of similar scrolls.
Precisely, and this isn't limited to text.
Right.
You could apply this approach to any type of data where there's enough underlying structure and patterns, like damaged photographs, incomplete musical scores, or even fragmented DNA sequences.
That's incredible. It's like giving these historical artifacts a second life. Okay, let's dive into another key aspect of AUNN's tokenization. Now, I'll admit, this is where I started to get a little lost in the technical details.
Okay.
Can you break down how AUNNs handle tokenization in a way that even I can understand?
Sure, tokenization is how AI models process data, breaking down raw information like text or images into smaller, more manageable units called tokens.
Right.
What's interesting about AUNNs is that they can handle different levels of data representation, from raw bytes to more abstract tokens like words or phrases. They achieve this by concatenating or combining all possible tokenizations of the data.
Hold on, concatenating all tokenizations? Doesn't that seem a bit excessive?
It might sound counterintuitive, but it's actually a brilliant strategy.
Really?
Imagine you have a sentence like, "The cat sat on the mat."
Okay.
An AUNN can learn from the individual letters, the words, and even phrases all at the same time because it has access to all these different tokenizations combined together.
So it's like the AUNN can see the forest and the trees at the same time.
Uh-huh.
It learns from the most basic building blocks, but also understands the bigger picture.
Exactly. This flexibility allows AUNNs to learn from a much wider variety of data sources and formats, from raw bytes to highly structured data.
That makes sense. It's like the AUNN is a universal translator for data. It can understand and learn from anything you throw at it. Okay, now for the speed round, I'm hearing whispers that AUNNs could be incredibly fast at runtime, potentially even faster than transformers. Is that hype, or is there some truth to that?
That's one of the most exciting prospects of AUNNs. Because they rely on these simple feed-forward computations, they have the potential to be incredibly efficient, especially compared to transformers, which use complex attention mechanisms that can be computationally expensive.
So once an AUNN has been trained, making predictions is a breeze. It's like having instant access to all the knowledge it needs without having to search through a massive database.
Got it.
Yeah.
This speed and efficiency could revolutionize applications that require real-time interaction, like chatbots, or those that deal with very long sequences of data, like machine translation or video generation.
Okay, we've covered a lot of ground here. We've talked about the simplicity, the potential for meta-learning real-world applications like reconstructing ancient scrolls, the magic of tokenization, and this incredible runtime efficiency. But before we get carried away, I have to ask, are there any downsides to this approach? What are some of the limitations of AUNNs?
That's a great question. No AI approach is perfect, and AUNs certainly have their limitations.
Okay.
One potential concern is their reliance on memorization. While this can be a strength, it could also be a weakness if the model encounters data that's very different from what it was trained on.
So it's like if you only ever studied one subject, you might struggle to apply that knowledge to a completely different field.
That's a good way to put it.
Okay.
AUNNs might need additional mechanisms to handle novel situations or to adapt to changing data distributions.
Okay, that makes sense. Anything else? I mean, these models must be massive, right? Doesn't that create some practical challenges?
Absolutely. The sheer scale of AUNNs is another limitation.
Okay.
Training and running these models requires massive amounts of data and computational resources, which could be a barrier to entry for some researchers or organizations.
So it's like needing a supercomputer just to handle one of these AUNNs.
Yeah,
That sounds expensive.
it can be. But remember, technology is constantly evolving.
Yeah.
As computing power becomes cheaper and more accessible, this limitation might become less significant over time.
Okay, so it sounds like AUNNs are still in their early stages of development. There's a lot of potential, but also a lot of challenges to overcome. What are some of the key areas of research that you're most excited about in this field? What are the big questions that researchers are trying to answer?
One area that I'm particularly fascinated by is the development of new training algorithms that can make AUNNs even more efficient and scalable.
Okay.
Researchers are exploring techniques for compressing data, optimizing training procedures, and even designing specialized hardware that can accelerate the training process.
It sounds like we're on the verge of a hardware revolution to match these software advancements. It's like the AI world is about to get a major upgrade.
Exactly. The development of AUNNs and other large-scale AI models is driving innovation across the entire tech landscape.
That's really exciting. Anything else on your radar? What are some of the other big questions that researchers are grappling with?
Another area that I'm really keen on is exploring ways to incorporate more structured knowledge into AUNNs.
Right.
Right now, they're mostly focused on learning from raw data, but there's a lot of potential to integrate them with symbolic AI systems or knowledge graphs.
So it's like combining the raw processing power of an AUNN with the reasoning and logic of more traditional AI systems, like a hybrid approach?
Exactly. And this kind of hybrid approach could lead to AI systems that are not only more knowledgeable, but also more capable of reasoning and problem solving at a higher level.
Okay, this is all incredibly fascinating, but I have to admit, it's also a lot to take in. It's like drinking from a fire hose of information. For someone who's just starting to learn about AUNNs, what's the one key takeaway you want them to remember?
I think the most important thing is to stay curious and open-minded.
Yeah.
AUNNs represent a radical shift in how we think about artificial intelligence.
Right.
They challenge our existing assumptions and open up a whole new world of possibilities.
It sounds like we're on the cusp of a new era of AI, and AUNNs are leading the charge. Well, on that note, we're going to take a quick break to let all this information sink in. We'll be back in just a moment to continue our deep dive into the world of absolute unit neural networks.
Welcome back for the break. We were discussing how AUNNs are pushing the boundaries of AI by scaling up these simpler models.
Yeah, it's like they're saying, hey, let's see what happens when we just take this like classic neural network and supersize it.
Exactly.
But I have to ask, how do you even begin to train a model that's trying to memorize an entire data set? Isn't that just a computational nightmare?
It's definitely a massive undertaking,
Yeah.
but there are strategies to make it more manageable.
Okay.
The key is to focus on learning the underlying patterns and relationships in the data rather than memorizing every single bit. Researchers are using techniques like efficient data representation, strategic sampling, and clever training algorithms to make this process more efficient.
Okay, so it's not just about brute force memorization, there's some finesse involved too. I'm especially curious about those different training modes you mentioned earlier, kind of like switching between like an RNN and a transformer style.
Uh-huh.
Can you elaborate on that?
Absolutely. The research outlines two main approaches to training AUNNs,
Okay.
each with its own strengths and weaknesses. The first is a serial approach, similar to how RNNs process data sequentially. It's like learning a new language by studying one grammar rule at a time, mastering each concept before moving on.
So it's very thorough, but potentially slower.
Exactly. It's sample
Yeah.
efficient, meaning the model learns a lot from each data point,
Okay.
but it can be computationally demanding, especially for massive data sets.
Okay. What's the other approach?
The second approach is more like a transformer, where you train on large batches of data simultaneously. Imagine trying to learn a language by immersing yourself in conversations and picking up patterns naturally.
Oh, okay. So it's faster, but maybe less precise at first.
That's a good way to put it. It's more computationally efficient, but might not be as effective for tasks that require a deep understanding of sequential information or long-term dependencies.
It sounds like each approach has its trade-offs. Is there a way to like combine them to get the best of both worlds?
That's a really clever part.
Yeah.
Researchers are experimenting with hybrid approaches, starting with large batch training to get the model up to speed, and then gradually transitioning to serial training to fine-tune its ability to handle more complex sequential information.
So it's like starting with the broad strokes and then filling in the details.
Uh-huh.
That's pretty ingenious. Okay, let's switch gears and talk about runtime efficiency. We've heard that AUNNs could potentially be much faster than transformers, especially when it comes to generating text or other sequential data.
Right.
How do they achieve that kind of speed?
It all boils down to their architecture, remember. Transformers use those complex attention mechanisms that have to analyze relationships between every element in a sequence. It's a bit like having to reread an entire paragraph every time you want to write the next sentence.
Okay.
With AUNNs, once the model is trained, predicting the next data point is just a matter of a single swift calculation.
So it's more like having instant access to the relevant information without having to sift through the entire data set.
Uh,
That's a huge advantage for tasks that require real-time responses.
exactly. Think about chatbots, real-time translation, or even generating realistic video content. AUNNs could significantly speed up these processes.
Okay, we've talked about the potential, the training methods, and these impressive speed advantages,
Right.
but let's be real, no AI approach is without its limitations. What are some of the downsides of working with AUNNs?
You're right. Every technology has its trade-offs.
Right.
One potential concern with AUNNs is their reliance on memorization.
Yeah.
While this can be a strength, it can also be a weakness if they encounter data that deviates significantly from their training set. It's like trying to navigate a new city, using a map that's slightly outdated.
So they might struggle to adapt to novel situations or to generalize their knowledge to completely new domains.
That's one challenge researchers are exploring. Another concern is the sheer scale of these models.
Right.
Training and running AUNNs can be incredibly resource-intensive, requiring massive amounts of data and computational power.
Yeah, it's like needing a supercomputer just to handle one of these things.
It can be a significant investment, for sure.
Right.
However, remember that technology is constantly evolving.
Yeah.
What seems like a barrier today might become commonplace tomorrow as computing power continues to advance and become more accessible.
That makes sense. It sounds like we're still in the early stages of figuring out how to best utilize AUNNs.
Yeah.
What are some of the key research directions that you're most excited about?
One area I find particularly fascinating is the development of new training algorithms that can make AUNNs even more efficient and scalable. Imagine training these massive models using a fraction of the current resources. That's the kind of breakthrough that could truly unlock their potential.
It's like finding a shortcut through the computational maze. What other exciting developments are on the horizon?
Another area that's really capturing my attention is exploring ways to incorporate more structured knowledge into AUNNs.
Oh,
Currently, they mainly learn from raw data, but imagine combining that with the logic and reasoning capabilities of symbolic AI systems or knowledge graphs.
so it's like merging the intuitive pattern recognition of AUNNs with the structured knowledge of a vast encyclopedia.
Precisely, this hybrid approach could lead to AI systems that are not only more knowledgeable, but also capable of reasoning and problem solving at a much higher level.
That's an incredible thought. AUNNs seem to be pushing the boundaries of what we thought was possible with AI. It's almost like we're witnessing a new kind of intelligence emerging.
It really is.
But as with any powerful technology, there are potential risks and ethical considerations to take into account.
You're absolutely right. We need to approach the development and deployment of AUNNs with a sense of responsibility and foresight.
Okay, on that note, let's shift our focus to the broader societal implications of AUNNs. We'll be back in a moment to explore the potential impact of this technology on our world. Welcome back to the deep dive. We've been exploring this mind-blowing concept of absolute unit neural networks.
Yeah,
And it's not just the technical stuff that's fascinating.
right.
The potential societal impact of AUNNs is huge. I mean, we're talking about models that could potentially learn to plan and reason at a level we haven't seen before.
That's right. These capabilities could revolutionize countless fields.
Yeah.
Imagine AUNNs helping us tackle complex challenges in medicine, climate, science, engineering, you name it.
It's like having a team of super intelligent assistants working around the clock
Right.
to solve some of humanity's biggest problems. But with that kind of power comes a lot of responsibility, right?
Absolutely. As with any transformative technology, we need to be incredibly thoughtful about how we develop and deploy AUNNs.
Right.
It's crucial to ensure they are aligned with human values and that we have safeguards in place to prevent unintended consequences.
It's like we're standing at the edge of a new frontier.
Yeah.
The possibilities are exhilarating, but we also need to proceed with caution. You know, one specific example from the research really stuck with me. It was about an AUNN learning to play chess by essentially internalizing an entire game tree. If a model can strategize and make complex decisions like that in a game,
Right.
what other domains could this approach be applied to?
The potential applications are vast. Imagine AUNNs helping to optimize traffic flow in cities,
Wow.
personalize education based on individual learning styles, or even design more efficient and sustainable energy systems.
Those are some pretty amazing possibilities.
Yeah.
But it also makes you wonder, what are the potential downsides?
Right.
What happens if these systems start operating in ways we don't fully understand or can't control?
That's why ongoing research and open discussions about the ethical implications of AUNNs are so important. We need to involve not just scientists and engineers,
Right.
but also policymakers, ethicists, and the public at large.
It's like a collective responsibility to ensure that this technology is used for good.
Yeah,
We need to anticipate potential challenges and work together to develop solutions.
exactly. And that involves promoting transparency, accountability, and ongoing dialogue about the values and principles that should guide the development and deployment of AUNNs.
Okay, so as we wrap up this deep dive, here's the question I want to leave our listeners with. If AUNNs truly achieve this level of sophistication,
Oh.
what kind of future do we want to build with this technology?
It's a profound question and one that deserves careful consideration. The future of AI is not predetermined.
Right.
It's shaped by the choices we make today.
So let's make those choices wisely. Thanks for joining us on this exploration of absolute unit neural networks. Until next time, keep learning, keep questioning, and keep imagining the possibilities.
And remember, the future of AI is in our hands.